Hello, in this session we are going to learn logic gates as applications of diodes. So we'll study two different logic gates where the circuits are constructed using diodes. Here, to study the logic gates, we are going to use positive logic. In positive logic, higher voltage is considered as logic state 1, whereas lower voltage is considered as logic state 0. This is the circuit diagram of two input OR gate. Here we have used two diodes D1 and D2. Anodes of the two diodes, that is terminal A and B, will be the two inputs of the OR gate. Cathodes of the two diodes are connected together to ground through this resistor R, and output voltage will be measured across this resistor R. This part of the circuit will be used to give high voltage to inputs A and B or to connect them to ground. That means we can keep these two inputs in logic state 0 or in logic state 1. When the anode of any diode, that is either input A or input B, is connected to ground, the diode D1 or D2, the anode of which is connected to ground, will be in reverse bias condition and it will act as open switch. The input which is connected to ground will be considered as in logic state 0. When the anode is connected to high voltage, that is when A connected to V1 and B connected to V2, the particular diode anode of which is connected to higher voltage will remain in forward bias condition and it will act as closed switch. The input which is connected to high voltage will be considered as in logic state 1. When a diode is in its forward bias condition, it will be replaced by a short circuit. Ideally, resistance of a short circuit is 0. But when diode is in its forward bias condition, its resistance is not 0, but it will have a small value which is static resistance of a forward bias diode. Now let us assume that both the inputs A and B are connected to ground, that means they are in logic state 0. In this case, both the diodes will be acting as open switch because they will be reverse bias. Now there won't be any current flowing through the resistor R, that means the output voltage will be equal to 0 and that will be in logic state 0. If A is connected to ground, that means A is kept in logic state 0, diode D1 will be reverse bias and it will be an open switch. At the same time, if B is connected to V2, it will be in logic state 1 and diode D2 will be forward bias and it will be acting as a closed switch. In this case, there will be current flowing through the resistor coming from the power supply V2. Voltage across the resistance R, that is the output voltage, will be now equal to V2. That means the output will be in logic state 1. Similarly, if A is connected to V1, that means A is in logic state 1. Now D1 will be replaced by a short circuit because it is going to be in forward bias condition. And if B is connected to ground, B is in logic state 0 and D2 will be reverse bias and so it will be replaced by an open switch. In this case, current may flow through resistance R in the direction shown over here. Now, the output voltage, that is voltage across R, will be the power supply voltage V1. That means the output will be in logic state 1. If A and B both are connected to the power supplies V1 and V2 respectively, both the inputs A and B will be in logic state 1. In this case, both the diodes D1 and D2 will be forward bias and will be acting as closed switches. This will give current flowing through the resistance R and the output voltage will be a positive voltage which will keep the output in logic state 1. Thus, we find that for the circuit shown over here, the truth table can be written as A and B as the two inputs and state of the output will depend on the states of the two inputs A and B. When A and B both are in logic state 0, output will also be in logic state 0. If either A or B is in logic state 0, whereas the other one is in logic state 1, the output remains in logic state 1. When both the inputs A and B are in logic state 1, again the output is in logic state 1. This is the truth table of OR gate. Let us now see the circuit of AND gate. So this is the circuit diagram of two input AND gate. Terminals A and B, which are the cathodes of the two diodes D1 and D2, will be the two inputs of this AND gate. Anodes of the two diodes are connected together to a positive terminal of this power supply through a resistance R. Output voltage of this gate is now the voltage across R plus the power supply voltage V. To give different logic states to the inputs A and B, we again use a circuit of the same type that we use for the OR gate. In this case, the voltages of these two power supplies, that is V1 and V2, both will be greater than or equal to the voltage V of this power supply. If A and B both are connected to ground, that means if A and B both are in logic state 0, the diodes D1 and D2 both will be forward bias and will act as closed switches. Now this output terminal gets connected to ground through either this path or this path, and so the output will be in logic state 0. If A is connected to ground and B is connected to V2, A will be in logic state 0, whereas B will be in logic state 1. Now D1 will act as closed switch, whereas D2 will act as open switch. The output terminal is now connected to ground through the path of D1. If A is connected to V1 and B is connected to ground, that means if A is in logic state 1 and B is in logic state 0, D1 will be an open switch but D2 will be a closed switch, and again output terminal is connected to ground now through the path of D2. So again output will be in logic state 0. Whereas if A and B both are connected to the positive terminals of the power supplies V1 and V2, A and B both are in logic state 1. In this case, both the diodes D1 and D2 will be reverse biased and acting as open switches. So this particular part of the circuit is disconnected from the other part of the circuit. Now there won't be any current flowing through the resistance, and so output voltage will be now just the voltage of the power supply V. That means output will be in logic state 1. Hence we get the truth table of AND gate as shown over here. When A and B both are in logic state 0, the output will be in logic state 0. When either A or B is in logic state 0 with the other input in logic state 1, output will again remain in logic state 0. Only when A and B both are in logic state 1, the output will be in logic state 1. This is the truth table of AND gate. In this session, we studied working of circuits of logic gates and OR as applications of diodes. Thank you.